On homework 5.6, you guys are using the quadratic formula to solve quadratic equations. It's a lot slower than using factoring, but there are lots of problems that cannot be solved without the quadratic formula. So we'll see that here. And I'll start out with number 1, just to give us make sure everybody understands the quadratic formula. First of all, you need to know the quadratic formula. Hopefully you have it memorized. If not, this would be a good time to try to write it down. The quadratic formula says that the values of the variable will equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And so that's what we're going to be using here. I do not like it when the a value is negative. It makes simplification a little bit harder, and you're more likely to mess it up. So if I ever see the a value is negative, if it isn't an equation, I will factor out the negative. If there is an equation, I will divide by -1 on both sides, and I'm going to start by doing that. I'm going to divide by -1, and what this does is it flips all the signs. So now it'll be positive 7k squared plus 3k minus 20 equals 0 divided by -1 is always 0. So my a is 7, my b is 3, and my c is -20. So the values of k will be k equals -3 plus or minus the square root of 3 squared minus 4 times 7 times -20 all over 2a, which is 14. I can simplify as much or as little of this as I want in my head. I know that this is going to be the square root of 3 squared is 9. Here, -4, it doesn't matter what order you multiply in. This is not distributing. Be very careful. Distributing only happens when there's a plus or a minus. Here we have 3 things multiplying together. You could multiply the first 2 together and then multiply times the third one. Or you can multiply in any order you want. I'm actually going to choose to multiply the first one and the last one together because it looks easier. -4 times -20 is positive 80. Positive 80 times 7 is 560. So it's plus 560. So it's -3 plus or minus 560 all over 14. So this is, I'm going to rewrite it up here, -3 plus or minus the square root of 569. All right, all over 14. Now, without a calculator, I might want to see like what could the square root of 569 be. And the first thing I do is I see, are there any square numbers that go into it? This is too big a number for me to know the square root of it, so I start looking for square numbers that could go into it. 4 can't go into it because this is not an even number, and 4 can only go into even numbers. 9, to see if 9 goes into this, I can add up the digits, and if the digits all add up to a multiple of 9, then 9 will go into this. 5 plus 6 is 11, 11 plus 9 is 20, and 9 does not go into 20, so 9 doesn't go into this. 25, or 16 can't go into this because it's not even. 25 can't go into this because it doesn't in a 5. We start getting to kind of weird numbers. Maybe 49 goes into it, which would mean that 7 would have to go into it. I can look at this and see that 7 does not go into it. 11 is the next like prime number. I might want to see, does that go into it? And 11 does not go into it. So as I start looking through this, it's not looking like I can simplify this square root. And since I can't simplify the square root, this might just be my final answer. I'm going to do a little bit more checking and make sure that it can't be simplified any. But I'm becoming more and more convinced that it's not simplifiable. And so my answer just is that k equals -3 plus or minus the square root of 569 all over 14. Okay, let's do number 3, which comes out somewhat different. This time, the quadratic equation is not equal to 0. Because it's not equal to 0, I need to first start by making it equal to 0. So I add 7 to both sides, get 11x squared plus 10x minus 5, 10x minus 5 equals 0. A is 11, B is 10, C is -5, and so I'm going to jump straight into doing the quadratic formula. And so it's going to be -b plus or minus the square root of b squared. So x is going to equal negative 10 plus or minus the square root of b squared, which is 100, minus 4 times a times c all over 2a. Okay. I'm going to simplify the square root a little bit, the stuff inside the square root. Negative 4 times negative 5 is positive 20. 20 times 11 is 220. And 100 plus 220 is 320. All over 22. All right. Now this one I can definitely simplify. I know that 16 goes into 32, and 16 is a square number. So I'm going to, off to the right here, I'm going to simplify this square root. Square root of 320 is equal to the square root of 16 times the square root of 20. 16 times 2 is 32. I can do the square root of 16. That's 4. I can also find a square number that goes into 20. 4 goes into 20. So the square root of 4 times the square root of 5 will give me the square root of 20. And I can do the square root of 4. This 4, that comes down. I can do the square root of 4, that's 2, times the square root of 5. And so this square root simplifies to 4 times 2 is 8, times the square root of 5. I cannot do the square root of 5 because there are non-perfect squares that go into it, so there's no way to simplify it. One thing I see students mess up on every once in a while is they'll say, like, oh, square root of 16 is 4, square root of 4 is 2. But nowhere does it say we're doing the square root of 4. 4 is 4, not 2. 4 is not equal to 2. So this is negative 10 plus or minus 8 times the square root of 5 all over 22. And this can be simplified because all of them are divisible by 2. The way to simplify a fraction is you can't just simplify one part of it. Notice that there's a plus here. What we are allowed to do is factor out a common factor from both the numerator and the denominator. 2 times negative 5 plus or minus 4 square root of 5. Notice that 2 times negative 5 is negative 10. And 2 times 4 square root of 5 is going to give me 8 square root of 5 all over 2 times 11. And because 2 is both multiplying and dividing, and it's a common factor, I can divide both the numerator and the denominator by 2. And my answer will be that x equals negative 5 plus or minus 4 square root of 5 all over 11. So that is my simplified form. Okay. Let's see, are there any tricky ones in the back? Not really. That's how a quadratic formula works. I don't think there's anything particularly difficult. I hope that helps. I will go over one more. Let me do number 6. Just because there's something interesting we can do here. We can make the numbers a lot easier on number 6 if we notice that there's a common factor at the very beginning. Because on number 6, these can both be divided by 6. If we were factoring, we would factor out the 6. But because there's an equation, we can just divide both sides by 6. So x squared minus 9 equals 0. And if we do the quadratic formula, a equals 1, b equals 0, c equals negative 9. So we're going to get negative 0 plus or minus the square root of b squared, which is 0, minus 4 times 1 times negative 9 all over 2 times a, which is 2. Okay. Negative 0 is just 0, and 0 plus anything is the thing you added. 0 minus anything is the thing you subtracted, but negative. And so this is just plus or minus the square root of negative 4 times negative 9 is 36. 36 times 1 is 36. So we end up with 0 plus 36, which is 36 all over 2. The square root of 36 is 6, plus or minus 6 over 2. We can divide this. 6 divided by 2 is 3, and we get plus or minus 3. X is positive or negative 3. Now, at the very beginning, you may have noticed that this is a really easy one to factor. When the numbers come out to be whole numbers, it means you could, or even rational numbers, it means you could have factored it at the very beginning. Let's see how that looks. Factoring x squared minus 9 is x plus 3 times x minus 3 equals 0. And then we can use the zero product property to just say that x equals -3 or x equals 3. Obviously, when we can factor, it's much faster. On these first two, these are crazy numbers. These are irrational numbers, and there's no way we could have factored to be able to get this. So we do need to use the quadratic formula sometimes, but let's not forget how to factor, because a lot of times factoring will be much faster. Hopefully that helps. On the back, there's a lot of ones where you'll need to make sure it's equal to 0 first, and that involves steps like, okay, there's multiple sets of p squareds. We're going to subtract 7p squared, subtract 6p. Oh, that comes from this. And so we get -p squared, 6p minus 6p is 0, plus 10 equals 0, and go from there. I'm going to let you guys do that on your own. Hopefully this was